All right, so we'll be differentiating using first principle. Now, having learned how to differentiate, there are certain questions you'll be given and you'll be asked to differentiate using first principle. Now, for example, I have a question like this: y is equal to 2x plus 4. Find the derivative using first principle. We all know that when you differentiate y with respect to s, differentiate 2s, you have 2, differentiate 4, so the answer is 2. But then some examiner wants you to use what? First principle to arrive at that 2. So in such case, how do we solve using first principle? Anywhere you see y, add change in y, and anywhere you see x, add change in x. So this is the question: y equal 2s plus 4. So this is the easiest way to solve first principle. So where you see y, add change in y. Where you see x, add change in x. So you see, since there is x here, you add change in x. You bring the bracket, then plus 4. At this point, we can have something like this: y plus change in y equal to 2 times x, 2x. 2 times change in s will give us 2 change in x plus 4. Then, what do we do next? You bring in the value of y. Replace the value of y. Change in y becomes 2x plus 2 change in x plus 4 minus y. So this y will come this way. Remember that this y is 2x plus 4. So remember to replace the value of y with its original value. So it becomes change in y equal 2x plus 2 change in x plus 4 minus the value of y. Y is what? Please put this in bracket, 2s plus 4. Because the minus is going to affect everything in the bracket. So if it's just one term, you can drop it like that. But since we have two terms, if it's two or more than, if it's more than one term, 2, 3 or more, always ensure to put that in brackets if you have a negative sign here. Because the negative sign will affect every term in the bracket. So it becomes change in y equal 2x plus 2 change in x plus 4. Minus times 2s minus 2x minus times plus 4 gives us minus 4. There is one simple trick I like telling students when solving first principle. Note that all the elements of y will be cancelled out. All elements of y will be cancelled out. How? 2s minus 2s. 4 minus 4. You see? You are left with what? Change in y equal to 2 change in x. As change in x, okay, now you divide both sides by change in x. So at this point, change in y divide change in x equal to 2 change in x divide change in x. Change in s cancel change in s, therefore the derivative of y with respect to s is what? 2. Answer. Okay, example 2. Let's take another complex question. Let's say you have y equal 3x squared plus 2s minus 4. Find the derivative using first principle. We know that when you differentiate this normally, if you differentiate 3s squared, your answer will be 6x. Differentiate 2s, you have 2. So the answer is 6x plus 2. Some examiner will want you to use first principle to get your derivative. So the law still remains the same. Where you see y, add change in y. Where you see x, add change in x. Remember, this is s squared. So you see, the change in s plus the x, then you bring the exponent here, this power, plus 2. Here you see x, add what? Change in x, minus 4. Now let's expand the bracket. This becomes y plus change in y equal, if you work this outside, please take note, x plus change in x all square is the same thing as x plus change in x times x plus change in x. X times x, x square. S times change in x, s change in x. Then you move to change in s. Change in s times x, s change in x. Change in s times change in s give us change in s all square. So I think these two, they are common. S change in s plus s change in s will give us 2s change in s plus change in s all square. So we cannot bring this into our workings here. 3. So when we expanded s plus change in s all square, it gave us x square plus 2s change in x plus change in x all square plus 2x plus change in x minus 4. Okay, now let's expand the bracket here. 3 times x square, 3x square. 3 times 2s change in s will give us 6s change in x. 3 times change in s all square will give us 3 change in x all square. 2 times x, 2x. 2 times change in x, 2 change in x minus 4. So bring y to this side of the equation. So we have change in y equal 3x squared plus 6x change in x plus 3 change in x all square plus 2x plus 2 change in x minus 4. If this y crosses to this side, becomes what? Minus y. Then remember to substitute the original value of y, which is what? 3s squared plus 2s minus 4. So this becomes change in y equal 3x squared plus 6x change in x plus 3 change in x all square plus 2s plus 2 change in x minus 4 minus the value of y. Remember I said you should put them in what? In brackets. And that's what? 3x squared plus 2x minus 4. Then let's expand that bracket. 3x squared, 6x change in x, plus 3 change in x all square, plus 2s, plus 2 change in s, minus 4, minus times 3s squared, minus 3s squared, minus times plus 2s, minus 2x, minus times minus 4 is plus 4. And remember I said all the values of y will be cancelled out. It's a must so long you are working with this method. So 3s squared minus 3s squared. 2s minus 2s minus 4 plus 4. You see, we've cancelled out all values of y. Then we can bring all the remaining numbers down. Change y becomes 6s change in x plus 3 change in x all square plus 2 change in x. I think these ones, they are all cancelled out. So the next step is to divide through by change in s. Divide through by change in s. Okay, so we have change in y divide change in x equal to 6x change in s, 6s change in x divided by change in x plus 3 change in s all square 3 change in x all square divide change in x plus 2 change in x divide change in x. As change in x tends to 0. So change in x, we cancel change in s. We are left with what? 6x. Change in s, we cancel one of the change in s. We are left with what? 3 change in x. Change in s, cancel change in s. We are left with 2. So remember, we say as change in x tends to what? 0. So this becomes 3 times 0. Change in x tends to 0. So our final answer is 6x. 3 times 0 is 0 plus 2. So 6x plus 2. So you see, with the ordinary method, to give us the same answer. I believe we know how to solve with the normal principle, which I have explained in the previous video. Use the power to multiply the question and subtract one from the power, and the same thing applies. So this is a more complicated question. So we'll also solve one more question before we finalize the first principle approach to derivative or differentiation.